So this video is for 7-4, adding and subtracting rational expressions. And our objective, it says find the least common denominator, but our objective is really to add and subtract rational expressions. You worked on an activity today in class in small groups, and some things you should have found out at the very beginning were, if you were adding and subtracting rational expressions, one thing you should always check for is whether or not they have common denominators. If the answer to that question is yes, then you can go ahead and add and subtract like terms in your numerator. If you are subtracting, you'll have to be really careful to make sure that you distribute the negative to all terms in the second numerator. One way you can get around this is changing it to adding the opposite, or just make sure you subtract all of the terms in the second fractions numerator. Also, remember that when adding fractions, after you have common denominators, keep the denominator. You don't do any math in the denominator when adding or subtracting rational expressions, just like regular fractions. If you found out that the answer to your question of common denominators was no, some things you should have talked about in your small groups were you would factor or look at the factors in the denominator to find the least common denominator. That's called the LCD. You would have to multiply both the numerator and the denominator by any missing factors. And then all your work will be up in the numerator, so you're going to add and subtract like terms in the numerator again, and you're going to keep your denominator or your LCD once you find it. So I'm going to show you just a couple of quick examples, and these are some of the more challenging examples. So here's an example where we have x divided by x squared plus x minus 2 plus 1 over x plus 2. If I look at my denominators right away, because I'm being asked to add fractions, I can easily see that they don't have common denominators. Now in this one, we have a trinomial in one of our denominators, so one thing we'll want to do first is go ahead and factor that denominator to see if the two fractions share any common factors. So let's go ahead and factor x squared plus x minus 2. Trinomials factor into two binomials that are getting multiplied together. To get the x squared at the front, I'm going to have an x and an x as my first term. And then I focus on the number in the back, which is negative 2. Do I have numbers that multiply to make negative 2, but add to make positive 1 in the middle? If I use positive 2 and negative 1, so plus 2 and minus 1, and this would be the factored form for x squared plus x minus 2. Now if I compare the denominators, x plus 2, x minus 1, and x plus 2, I can see that they share something in common. So my LCD, or my least common denominator, will have that factor of x plus 2, which they both have, but my larger denominator also has a factor of x minus 1, which my smaller fraction needs. So I'm going to multiply by the missing factor in the least common denominator, and I have to do that in both the numerator and the denominator. Okay. When I multiply by that x minus 1 in the numerator and the denominator, I have created two denominators that look exactly alike. So for the rest of my problem, I can use x plus 2 times x minus 1 for my denominator. You can multiply this out, but you don't have to. I usually don't, because that leaves me open to more errors. Then all the rest of your math work for this problem happens up in the numerator. We want to do x plus 1 times x minus 1. So x plus 1 times x minus 1. I will go ahead and distribute this positive 1, which leaves me with x plus x minus 1 all over x plus 2 times x minus 1. And then combine my like terms, 1x plus 1x will give me 2x minus 1 over x plus 2, x minus 1. Now, we mentioned in class that we should make sure our fraction is in its simplest form, meaning the numerator and the denominator share no common factors. You might check at the end if you could factor your numerator if it has any of the same factors as the denominator, but we can't factor 2x minus 1. They have no greatest common factor. So 2x minus 1 over x plus 2, x minus 1 is my final answer. Remember, don't get cancel happy and start crossing off x minus 1's here. We do not have a factor of x minus 1 in the numerator. Let's look at an additional example. Oops, went too far. 3 over x plus 4 minus x minus 2 over x squared minus 16. Again, it's pretty obvious if I'm looking to subtract these two fractions that I do not have common denominators. So step 1, if any of my denominators are factorable, I will factor it to see if they share any common factors. X plus 4 is not factorable, but x squared minus 16 is a difference of perfect squares. So we can factor this out as x plus 4, x minus 4. And then I can see that both fractions share a factor of x plus 4, which is going to be one of my factors for the least common denominator. My larger denominator also has a factor of x minus 4, so I'm going to need to give that to my first fraction. And so I have to multiply both the numerator and the denominator by x minus 4. At this point, I've created a common denominator, x plus 4 times x minus 4. You could multiply this out to get x squared minus 16. I'm not going to do that. That's more work, so I just keep my denominator. And all of my math now happens in my numerators. So I'm going to do 3 times the quantity, x minus 4, minus the quantity, x minus 2. When I do that, I'm subtracting all of the second fraction's numerator. So that's one of those things where we have to be really careful because we're going to distribute that negative. I'll go ahead and distribute the 3 to both terms, x minus 4, which leaves me with 3x minus 12. Now I'll distribute this negative, minus x, and then plus 2, all over x plus 4, x minus 1. And I can combine like terms in my numerator. I've got a 3x minus x, which gives me 2x. I've got a minus 12 plus 2, which gives me minus 10, and that's all over x plus 4, x minus 4. Now remember what we said, we should stop and check our numerator. If our numerator is factorable, we want to make sure that it shares no common factors with the denominator because then it's not simplified. I can factor 2x minus 10. It has a greatest common factor of 2, which gives me 2 times x minus 5 over x plus 4, x minus 4. But none of those factors are the same as the factors in the denominator, so either one of these would be an acceptable answer. Again, remember, if your fractions don't have common denominators to begin with, take the time to see if either denominator is factorable. You might be able to reduce the amount of work you do by finding if they have any common factors to begin with. I'll do one more example, and my final example will be 5 over x plus 3 minus 4 over x plus 1. I wanted to show this example because these two denominators are not factorable. X plus 1 doesn't factor, x plus 3 doesn't factor. Which means when I'm thinking about my least common denominator, or my LCD, the first fraction has a factor of x plus 3, and the second fraction has a factor of x plus 1. They share nothing in common. X is a term and not a factor, so I need both of those to be in my new denominator. This would be an example if you were trying to add 1/2 plus 1/3. 2 and 3 don't share any common factors, so we have to multiply the first fraction by 3 on the top and bottom, and the second fraction by 2 on the top and bottom. Over here, that will look like multiplying by x plus 1 in the first fraction, and multiplying by x plus 3 in the second fraction. Now my denominators are the same. It's okay that one is x plus 3, x plus 1, and the other x plus 1, x plus 3, because multiplication is commutative. So I could write it either way. I keep that denominator for the remainder of my problem, and all my math work for adding and subtracting now happens in my numerator. So I write this out as 5 times the quantity of x plus 1 minus 4 times the quantity of x plus 3, paying careful attention to the fact that I'm subtracting there. Go ahead and distribute your 5 and your -4 to both terms in the parentheses. So we have 5x plus 5 minus 4x minus 12 all over x plus 3, x plus 1. Combine the like terms. I've got 5x minus 4x, so that's 1x. And I have plus 5 minus 12, so that's going to give me a -7, all over x plus 3 times x minus 1. X minus 7 is an entirely different factor than x plus 3, x plus 1. It doesn't factor at all, so this is my final answer. When you're working on your homework problems, take the time to ask yourself, do I have common denominators? If I don't have common denominators, does either denominator factor? Focus first on getting common denominators, and then once you have common denominators, all of your math work happens in your numerator. Thanks a lot for watching. Best of luck.